Hey everyone, it's Federico here. Welcome to the second lesson of the course Let's Start with Jitter for Beginners. And yes, I did cut my hair after 4 years. I'm very happy about this choice. I really feel much more light in a way, like literally, but also psychologically. So yeah, with that out of the way, in this video we're going to talk about textures, so how to work with movies, as we saw in the previous video, but this time we will work with the movies as a stream of textures instead of as a stream of matrices like in the previous video, and this will allow us to play movies at a much higher speed if we will want to do so, and also will stress our CPU much less, because this system now works with a GPU, so the graphic processing unit. So let's start by seeing what is a CPU and what is a GPU, how this relates to play a video in Max, and without any further ado, let's jump into it. Have fun! So the first thing we're going to talk about is what is a CPU and what is a GPU in our computer. And this is important because, as we said, textures work using the GPU while matrices work using the CPU. So the CPU, and you can see here an Intel CPU core, and I put Intel because Intel is one of the biggest producers of processors, of CPUs. While here you can see NVIDIA, because NVIDIA is one of the biggest producers of GPUs, so graphic processing unit. So the CPU is the core processing unit, while the GPU is the graphics processing unit. So the core processing unit in our computer is a processor, which is responsible for basically everything. So when we browse the folders in our computer, when we open a browser, when we open Max, when we open any other program, the CPU is involved in that. So basically is the main processor, the core processor. The GPU, so the graphic processing unit, is the one responsible for everything that appears on the screen. So all the pixels that we are seeing right now, this is the job of the GPU to display those pixels, so to assign a color to each pixel. And it's also used, of course, in heavy graphical applications, like for example video games or playing movies or this sort of things, for example creating visuals in Max also. So why do actually our computers have these two processors? Well, that's because they are optimized for their relative task. So if we're talking about the CPU, it will be composed by 8 to 12 cores, and these cores are very powerful. So we can imagine the CPU like being a bunch of cores, like let's say 8 cores, that process all sorts of information in a very performant way. They're very good at processing lots of complex informations, but these informations can only be parallelized so much. This means the processors can only do a certain amount of operations at each computer cycle. So for example, if our CPU has 8 cores, this means that maximum we will have 8 operations in parallel happening at the same time in our computer. I'm really oversimplifying it a lot, but that's kind of the basic idea. While the GPU instead is made of a lot of cores, I will just draw a bunch of rectangles, you can imagine these are all cores in the GPU, and these cores perform a lot of more operations in parallel because they're just more cores. They're just not so powerful as the cores of the CPU, but the cores of the GPU are great in performing a lot of operations in parallel, right? And for example, what is an operation that really needs to be parallelized? Well, for example, drawing pixels on our screen. Since we have a lot of pixels, each refresh rate of the screen, these pixels must be adjusted to the new values. And this means that our computer has to process lots of information, which means this information, in order to be processed so fast, need to happen on a lot of cores at the same time in order for our monitor to display smooth animations. So that's why we got two different processors, the CPU and the GPU. So to recap, the CPU is the one which is responsible for complex operations but is not highly parallelized, while the GPU is highly parallelized but doesn't do really complex operations. So that's kind of the gist of it. It's by no means a very exhaustive explanation, but this is all we need to know when working with Max, I would say. So let's get rid of those. And let's see how we can use the power of the GPU in Max for the visuals. So for example, let's say we want to play a movie but use the GPU instead of the CPU, because as we said, playing a movie using the GPU is much faster for our computer than playing it using the CPU, like we were doing in the previous tutorial. So when we create a jit.movie object, let me just set volume 0 here, and let's create a jit.p window to display the frames. And let's just load a movie into it. Actually, what I will do is to set it as a default movie. So with the movie file attribute, I will just type the name of the built-in movie in Max, which is Sunflower MP4. Now, if I send a bang message to the jit.movie, and in the past video, in the past lesson, we sent the bang message using just a message we've written bang into it, but we can also use a button object. So this is a button object, which we can create with P. which does exactly that, sends out the message bank. So we can visualize it using the right inlet of this message box, for example. So this video that we're now playing, as we say in the last lesson, this comes out as a jitter matrix, right? And we can recognize that because we have this green cable. Actually, we got another way of recognizing that this is a jitter matrix, and this way is to use a message box and send the output of jit.movie in the right inlet of this message box. So we click on the bang button here, and as you can see, the message that comes out is actually jit matrix plus the name of the matrix. So maybe intuitively we will think that when we send a matrix to another object, we are sending the whole data of this matrix with this cable, but actually that's not the case. Actually, we are just sending the message jit matrix followed by the name of the matrix. So every object that receives this message knows that he has to go look into the RAM, the random access memory of our computer where Max is writing, where to find the data for this matrix. So this is like the address in memory that the other objects will go to look for when they receive this message. So let's write this down here. Jitter matrix reside in the RAM of our computer, right? In the random access memory of our computer that gets rewritten every time the computer needs to access it. And this is accessible from the CPU. Now let's see how we can transform this jit.movie from outputting matrices into outputting textures. So there is not another object to output movies as a textures. It's always the good old jit.movie. We just need to give it another attribute, which is output texture, and then we set it to 1. So we're telling the jit.movie to output now textures and not anymore matrices. And as you can see, the cables here changed colors. This became blue, which means this is now a texture cable. So let's try to now output this texture from the jit.movie object, and if we click here on the button object, nothing happens. There is no texture being output, and I also recreated this jit.movie window, and you can see that there is no image anymore into it. If I click the bang button, nothing is happening. Now, why is that the case? That's because the textures to work need an OpenGL context. So let's write this down. And you're probably asking yourself, what is an OpenGL context? An OpenGL is this set of commands that our programs, like for example Max, use to communicate with the GPU. When we are writing a program in C, like Max for example is written in the programming language C, C will be the language responsible to transfer instructions to the CPU to execute certain tasks. Now, when wanting to send instructions to the GPU instead, we need to use something like OpenGL. OpenGL is then a set of commands to communicate with the GPU. This is also called an application programming interface, or API. So Max uses this OpenGL library or API to communicate with the GPU. And in order for these commands to work, we need this OpenGL context. And that's why the texture is at the moment not working, because we don't have this context. Now, to create this context is super easy. We just need to create a jit.world object. And when I create a jit.world object, you can see that there is this black window appearing here. This is our rendering window, but when I click anywhere in the patch, this window will just disappear behind the patch. And what this jit.world does, creates this window which represents our OpenGL context. So now we have this whole system, this whole OpenGL system in place, which we can use with all our GPU objects in Max. All the objects, for example, that output textures, all they have GL in their names. There's only one thing that we need to do, which is to activate this jit.world. So we need a toggle, connect it to the jit.world, and set it on. So we are basically just sending the number 1 to the jit.world. If we send the number 0, this will be deactivated. If we send the number 1, this will be set on. So 0 deactivated, 1 is on. Great. So as you can see now, this jit.movie started automatically to output the movie. And as you can see, the message that we get out of the jit.movie is this GGL texture, and then there is the name, this time, of the texture. So that's not the name of the matrix. This time, this is the name of the texture. And as you can see, it's automatically playing. And that's interesting. We don't need anymore to send a bang to the jit.movie. The jit.movie is playing it automatically thanks to the jit.world which is running. Now, there is one important thing to mention, which is that the textures are not actually in the RAM, in the random access memory. They reside in the VRAM, so the video random access memory. And that's also a reason why playing movies as a flow of textures is much faster than having them playing in as jitter matrices. And that's because when we play a movie as a jitter matrix, We are basically sending this movie from the CPU memory to the video memory so that the GPU can then read it and display it as pixels. While if we have this movie output as texture, this video is already in the video memory of the GPU. That's why it doesn't need to be transferred from the CPU to the GPU, it's already there. And that's also what makes it better to use texture for playing movies. In the Mac system, and probably also in some other architectures, we have that there is a unified memory. So the CPU and the GPU share the same unified memory. So sharing data between the CPU and the GPU is not such a big deal anymore using these M1 Macs or M2. But still, it's good to know that there are two different types of memories, the RAM and the VRAM. And when we play a movie as a texture, this movie resides then in the video RAM. Now, in the previous lesson, we saw that we could choose the frame rate at which we were playing a movie based on the amount of bangs we were sending each second to the jit.movie. And now that it's playing automatically, actually, what is the frame rate at which this movie is playing at? Let's check it out. Let's use the FPS GUI object to see how many frames are coming out each second, and we can see that there are roughly 60 frames per second. This movie is playing at 60 frames per second. And why is that? Well, that's because the jit.world has by default, and if we right click here on its input, we can go into this FPS attribute. We can see that by default, this jit.world is refreshing, let's say, the OpenGL context 60 times per second. So every object that is implicitly using the jit.world for refreshing, like the jit.movie with output texture, will use this frame rate to process its content. So for example, here the jit.movie is outputting the video at 60 frames per second. If you want to change this frame rate, like for example set it to 15, you will see that this is not working. And that's because the jit.world, by default, it's linked to the refresh rate of our monitor. So our monitor has a certain refresh rate, right? It displays the images not as a continuous stream, but refreshes what we are seeing a certain amount of times per second. So the jit.world is automatically following this refreshing rate. In order to decouple the jit.world, the frame rate, from the refreshing rate of the monitor, we need to give it the attribute sync and set it to 0. So if I reactivate it now and I set the FPS to 15, you can now see that the jit.world is refreshing the OpenGL context only 15 times per second, and that's why we are getting a frame rate of 15 here now. We can also check the refreshing rate of the jit.world from its central output. Here there is the render draw bang, as you can see, which is a bang message that is sent out from the jit.world this many times per second, so 15 times per second, every time a new frame is rendered by the jit.world. So that's another way to measure our frame rate. But let's say now that we got two jit.movies playing textures, and we want to play these jit.movies at different frame rates. So for example, let's get another movie inside there. Let's get the b-ball movie that we saw in the previous lesson, right? And from the previous video, we know that this b-ball guy has a frame rate of 15 frames per second, was shot at a frame rate of 15 frames per second. If we also send the get FPS message to jit.movie, as we did in the previous video, you will see that it gives us the message FPS 15. While if we send a message here to the jit.movie that is playing the sunflower video, you will see that this movie has a frame rate of 29.97 frames per second. But we are playing both these movies at the same frame rate that we set on the jit.world. Like for example, in this case, if we set this to 60, we are playing a lot of unnecessary frames. And so what if we just want to play the necessary frames for each movie? So if this movie has 15 frames per second, if we play it at 60 frames per second, we are just actually seeing duplicated frames, because the same frames will be output more times to achieve these 60 frames per second, but the real frames of the videos each second are just 15. So there is a very useful attribute on the jit.movie which is unique. Now unique, if we set it to 1, will make the jit.movie only output a new frame when there is a new frame to play. So even if the jit.world is refreshing at 60 frames per second, this unique attribute will make this jit.movie output this video at 29.97 frames per second. So that's a great attribute to have. We mostly want to have it on. So let's set this to 1 directly inside the jit.movie object. And as you can see, when I recreate the jit.movie object, the first message that gets sent out from the right outlet of jit.movie is the read the message with the name of the movie that it has just read. Because since this movie is set as an attribute in the object, every time the object is created, it will read this video file and output the message read plus the name of the file plus a 1, which means, yeah, the reading of this movie went well and now it can play. So let's try, for example, to load another movie. And as you can see, now it says read countdown.mov, which is the name of this movie, and then 1, which means everything went well. So this is a very useful message in case we want to trigger something every time a new movie has been read. So that's a very useful bit of information. For example, we could trigger every time we load a new movie. We want to know how many frames per second this movie was actually shot at. So we can say here root read and root FPS. So what happens is that every time a new movie is loaded, we will have, from the first output of route here, we will have the name of the movie and the 1 part. Now we just want to know if this movie has been read correctly. So we just want the last elements of the last element of this list. So for that we can use the object list.htils.1, which will slice a list in reverse though. So from the right outlet it will give us the last element of this list. So if we try to read another movie, you can see that from here it will give us the number 1. This number 1 here means give us the last element from the list. So just one element starting from the right of the list. So going kind of from right to left. If we will set here a 2, it will give us 2 elements in the list. So it will give us actually the name plus this 1. But we just want the 1, so we set a 1 here, and then we can say select 1. And then every time this movie is read, we send the get FPS to the jit.movie object. And so let's try this movie. We know it's a 15 frame per second. And so on, this is also 15 frames per second. Okay, so that's an useful way to know how many frames a movie has just automatically when it's first loaded. So let's stop it here, and to recap, in this video we saw what is the CPU and what is the GPU. We saw that to play a movie is much better to work using the GPU, so using this texture output for the jit.movie object. In order to get the texture output to work, we need a jit.world, which will create an OpenGL context. OpenGL is this API or set of commands that allow Max to communicate with the GPU, so sending instructions to the GPU, for example, like output a frame now and display it, this sort of stuff. And the texture is an image that resides in the GPU, so in the video, random access memory, the memory of the GPU, the graphic processing unit. So that's what also makes it much faster to play a movie using the GPU instead of the CPU, because the computer doesn't need to transport the information from the CPU to the GPU. The information is already on the GPU. So that's where the source is. Thank you very much for following. A like to the video and a subscribe to the channel will be very much appreciated. If you want to get some more content, check out my Patreon where there are hundreds of patches, and there is also a Discord community which you can access. So I hope to see you in the next video. In the meantime, have fun, take care, see you soon, ciao.